Hi, everyone. We're going to look at solving equations involving like terms today. Okay, so the first thing we want to look at is some key things that we have to remember before we can start solving these types of equations. When we're looking at this, it's important to remember that a variable is going to be a quantity that can change. So we know that typically we see x as the variable, but it can really be any letter that is in an equation. So you could have b, you could have a. Some letters are not used very often, and some are used more than others. As I said, you often see a variable represented by x. But either way, what that's telling you is that whatever that variable is, that it's a quantity that can change and depends on the equation itself. So for instance, if we have 2x, our variable is going to be that x term, and then the 2 is going to be the coefficient that is going to go with x. Now, it's important to remember, too, that when you see it written like this, 2x, that would say that if you knew what that variable was, you would actually multiply those terms together. For instance, if x was equal to 1, and we found that out by solving, we could actually take 2 and multiply it by 1 to get our answer. Now, for this exercise that we're going to do looking at solving equations involving like terms, it's important to remember that like terms are going to be the same. They're going to have the same variable and they're going to be raised to the same power. So for instance, if you just have the number 2, that does not have a variable, and then you have 2x, those are not like terms. You cannot combine those. They have to have the same variable. And then in this case, which I know that just says 2x, but this is actually just raised to the first power. Okay, so if you had something like 2x squared, you would only be able to combine it with terms that have that variable raised to the same exponent. So as an example, we look at this question down here. We have 6x minus x, okay? And what we want to do is we want to look at the coefficients in front of these variables. So we know that we have this 6, and we know that we have that anytime you see a variable without a number, that's actually going to be represented by, and I'm going to change the color so we can see it, that's going to be represented by a 1. So in this case, we actually can combine these terms by saying 6 minus 1, and that's going to give us this 5, and then we're going to leave the variable there, okay? Because we still don't know what that variable is, but we know that if we combine those terms together, it'll make it easier to solve when we do know what the variable is. Okay, so I want to take a look at some examples of this. Okay, and some of these examples are going to ask you to actually solve for the variable, but there is going to be that additional step of combining those like terms of the equation. Okay, so let's take a look at this example. Now, in this case, we can see we're solving for a. That's the whole purpose of this. We are going to solve for what this variable is. We want to know what a is equal to. We have 5a minus 4a is going to be equal to 15, okay? Now, to make this a little bit simpler, we can say that we have 5a and we have a negative 4a, so we can see that they have the same variable, they're raised to the same power, so we can actually combine these before solving for anything. So I'm just going to put a circle around those terms that are like terms, and then we can look at what we're going to do from here. Okay, so we're going to combine these coefficients. So we're going to take 5 and we're going to subtract 4. Okay, now notice I left the variables out because right now we're only looking at those coefficients, but the variable doesn't go away. Okay, that's important to notate. So 5 minus 4 is going to give us an answer of 1. Now, when we bring the variable back in this case, we would have 1a, but as we stated before, as we went over, anytime you have that variable that does not have a coefficient with it, it is represented, it does say that it's 1a, 1x. So we can actually drop this number and just say a is equal to, and then we would just leave this as 15 because we solved for A. We found out that 1A or A is going to give us an answer of 15. Let's take a look at another one that's going to be, might be a little bit more challenging. Okay. So in this case, we have 7q minus 5q is equal to 16. Now, even though this is not a typical variable as far as what we talked about, we see x a lot and you can use a, b, it's still a variable. It still represents that number that quantity that can change. Okay, so we're going to do the same thing we did before. I'm going to put circles around those terms that are like terms to show me what I need to combine before I can solve. So 7q and then negative 5q. And this is important too to kind of pay attention to, is you always want to take that symbol that's in front of the term. So in this case, if you read this as a whole equation, it's 7q minus 5q. But when you separate those terms, we have a 7q, which is positive, and then we have a negative 5q. So that minus sign kind of doubles as a subtraction sign as well as a negative sign. Now we can actually solve. We can take these coefficients and we can say, okay, so I've got 7 minus 5, and that's going to give us an answer of 2. And then we're going to bring this variable back to this because now we have that coefficient that's going to go with the variable. We're going to say 2q is equal to 16. Now, this is actually bringing an additional step into this question. So before, when we solve for A, we just put A equals whatever the number is. However, in this case, we have 2q. So we want to figure out what 1q is going to be equal to. And this is where we're going to use inverse operations, okay? So inverse operations are going to be those operations that are going to undo what was done. So for instance, if you have addition, your inverse operation is subtraction. If you have subtraction, your inverse operation is addition. So those kind of go together. They're paired together, addition and subtraction. In the same sense, you have multiplication. So the inverse operation is going to be to divide. And then let's say you have division, or you have a fraction. That's kind of a good indicator that you have division. You're going to multiply. So in this case, if we knew what q was, what the number was, okay, we would multiply 2 times q. So in order to do the inverse operation, if we knew what q was, we'd multiply. The inverse is going to be the opposite, which is going to be to divide. So we're going to divide both sides. And what we want to divide both sides by is the number that is with q. We want to get rid of that number is what we want to do. So we're going to divide both sides by 2. Okay, and what this does is 2 divided by 2 is just going to give us an answer of 1. Okay, so that leaves us with just q, or 1q. And then we want to figure out, what is 16 divided by 2? Well, we know that 2 times 8 will give us 16. So 2 can go into 16 8 times. Now, we can also go back and check our answer. And I'm going to do this in a different color so we can see the difference between the check and the solving of the question. We would say 7 times 8, and then we would say minus 5 times 8 should give us an answer of 16, right? And now, yeah, it's important in this case to remember your order of operations, okay? We have to do parentheses, then exponents, and then multiplication and division go together, and then addition and subtraction will go together. So we're going to multiply first. We're going to multiply 7 times 8, which is 56, and we are going to multiply negative 5 times 8, which is a negative 40. Okay, now we have 56 minus 40, which will give us an answer of 16. And this is going to show us that this does check and this does work. So our answer in this case is going to be q is equal to 8. Okay. Take a look at another example. So we're going to move on to the next slide. And some of these examples are going to be a little bit more challenging than the others. Okay, as we can see in this case, we have a lot of variables here, and that's okay. The main point of this is just to solve for W. And we're going to make this look a lot nicer by combining those like terms. Okay, So the first thing I'm going to do is I'm going to put my circles around anything that has that variable that is the same. So right now we're looking for any term that has W. So we've got a 16W, we've got a negative W, we've got a negative 12W, and we've got a negative 2W. And now, since this is addition, subtraction, we're just going to go straight across, just as the order of operations tells us to do so, okay? So the first thing we're going to look at, and you can separate this too, okay? We're going to say 16, and I'm going to change the color so this is easy to see. 16 minus 1, because we know in front of that W is a 1. So 16 minus 1 will give us 15. Okay, and then we're going to say 15 minus 12 is going to give us 3. And notice how I'm just doing the numbers. So we did 16 minus W minus 12, and now we're going to subtract 2, which is just going to give us a 1. So all of this is going to combine to just give us a 1W, which we're just going to drop the 1 and we're going to say W equals, and then we bring down our answer of 13. So we don't really have to do any steps in this case. Okay. And again, check your answer with this. We can say 16 times 13 minus 13 minus 12 times 13 minus 2 times 13 should give us an answer of 13. And I'll pull up the calculator for this so that we can get check this, make sure. So in this case, we're going to multiply first. So 16 times 13 will give us 208 here. And then in this case, we're just going to subtract 13. Then we're going to check 12, negative 12 times 13 will give us a negative 156. So we're subtracting 156. And then we're going to say negative 2 times 13 will give us negative 26. And this should all be equal to 13. So when we go through and we solve this, we say 208 minus 13 minus 156, and then minus 26 will give us that answer of 13. So we can say that 13 does equal 13. And the point of checking is you want to get the same number on both sides of that equal sign. That's going to tell you that, yes, your answer is going to check, okay? So let's look at another one. There is going to be a good challenge question in here towards the end. This is also a challenge, similar challenge question than what we just did. So we're going to start by, again, we want to group our terms and combine them so that it'll make this question a lot easier to solve. So we're going to say, okay, 16G is one term, negative 11G is another, and then positive G is another. Okay, and now we can solve. We can take those coefficients. So I can say 16 minus 11 is going to be equal to 5. So I did these two already. And then we're going to add 1, which is going to give us an answer of 6. Now we have to bring that variable back down, and we want to say 6G is equal to 6. And again, this is where inverse operations are going to come into play, because if we knew what that variable was, we would multiply 6 times that number. So if we're going to multiply, the inverse operation would be to divide. To undo this question to find out what is G equal to, we're going to divide. 6 divided by 6 is going to give us an answer of 1. So we're just going to leave this as G equals. And then 6 divided by 6 is going to give us an answer of 1. So we can see that G is equal to 1. When we check this question, we're going to plug this in. Anywhere you see the variable, we're going to plug in the number. So 16 times 1 minus 11 times 1 plus 1 is equal to 6. 16 times 1 is 16, minus 11. 11 times, negative 11 times 1 is negative 11, and then plus 1. So we get 16 minus 11 is 5. 5 plus 1 would give us 6 is equal to 6. All right. And one last question, and this is where the challenge question is going to come in. Okay. This is going to have multiple steps. It is going to have you pay close attention to those variables. Okay. So again, we're going to follow the same steps that we did with the other questions. We want to start by grouping those terms that are like terms, okay? Anything that has the same variable. So 14x, that has a variable of x, plus 13x, so that we're going to put a circle around this one too, minus 10x, that also has the variable of x. But then we come to this last part, minus 6. There is no variable with 6. So in this case, I'm actually going to change the shape that I'm going to use, and I'm going to change the color because this is not the same as the rest of the terms that we see. So in this case, I'm going to put a box around the minus 6. That's going to tell me too that when I'm combining those terms, those circles, I'm going to combine all together, and that box I'm going to combine separately. It's going to stay by itself. So, and I'll show you exactly what that looks like. Okay, so 14, we have 14 plus 13 will give us 27. And then we have a minus 10. So we're going to subtract 10 from 27, which will give us 17. Now we come to the minus 6. We can't combine this with the rest of the terms because it's not alike. So we're going to rewrite this as 17x minus 6 is equal to 28. This looks a lot better, but there's still some additional steps that we have to do to figure out what x is going to be equal to. So with solving 1- and 2-step equations, okay, you want to solve using the reverse order of operations. So we know the order of operations is parentheses, exponents, multiplication and division are together, and then addition and subtraction are together. So the reverse order of operation is going to be SAD MEP. And again, subtraction and addition are grouped together, and multiplication or division are grouped together. But we're going to start in reverse order. So we'll start with subtraction and addition. So we're going to we have negative 6 here. And so the inverse of subtraction is going to be to add that number. We want to cancel this out. So we're going to add 6 to both sides. And then this number will cancel. It'll actually result in just a 0. Okay. And then we've got 28 plus 6, which we can say is 32. Now we have 17x equals 32. And so now we get back to that point before where if we knew what x was, we would multiply 17 times x. So if we knew that we would multiply the inverse in order to undo this to figure out what x is equal to, we would divide both sides by 17. And that would leave us with 32 divided by 17 will give us an answer of 2. And then we can go back and we can check this, plugging in the 2 wherever you see the x. So we would say 14 times 2 plus 13 times 2 minus 10 times 2 minus 6 is all equal to 28. We would say 14 times 2 is 28. 13 times 2 is 26. Negative 10 times 2 is negative 20, and then minus 6. And I'll put a plus sign. So then when we go into our calculator, we would say 28 plus 26 minus 20, and then minus 6 will give us that answer. We could say that 28 is equal to 28, and this equation would work. So our answer would be x is equal to 2.